Now let's take a look at Ronnie the Rational, Part 2. If you remember, f of x is equal to x squared minus 1 over x cubed. I took the first derivative in a different way in the first part. I'm going to show you how it's going to be easy to find the second derivative here. It's a lot easier if you actually divide up your fraction first. In this case, we can note that f of x is equal to x squared over x cubed minus 1 over x cubed, which reduces down to x to the negative first minus x to the negative third. When you take the first derivative, you bring that negative 1 power down just through the power rule, and you get negative x to the negative 2 plus 3x to the negative fourth. The second derivative will then be 2x to the negative 3 minus 12x to the negative fifth. This is all just power rule. It's going to be a whole lot easier if we actually go through and we factor out. You'll notice we've got a 2 in common, and we've got an x to the negative fifth as the lowest power. So we can factor out a 2 and the x to the negative fifth. As we talked about in a previous lesson, when we factor out an x to the negative fifth, that's 2 powers less than x to the negative 3, so we're left with an x squared. If you're not convinced, go ahead and multiply that back out. You'll see that negative 5 plus 2 is negative 3. And here, of course, we're just left with a negative 6. To make it a whole lot easier to actually find our critical points when we have to do that, which is our next step. Critical points for our first derivative are where f double prime is equal to 0, or where f double prime does not exist. I rewrote the second derivative right there for you. 2x to the negative fifth can be rewritten as 2 over x to the fifth. And of course we've got the x squared minus 6 part. The second derivative does not exist when x is equal to 0. That's because we're going to have a denominator problem. So therefore x is equal to 0 is a critical point of our first derivative. When we set x squared minus 6 equal to 0, we're going to get 2 critical points of root 6 and negative root 6. Now, time for the sign test. It's better to use the factored form right here to actually use your sign test. So we're going to take a number to the left of negative root 6, such as negative 3. When we plug that in here, we're going to get a negative here and a positive here. Negative 3 squared minus 6 is positive. Negative times a positive is a negative. A number in between negative root 6 and 0 is negative 1. When we plug that in, we're going to get a negative with the 2 over x to the fifth part, and a negative here. Negative times a negative equals a positive. We proceed in a similar way with x is equal to 1 and x is equal to 3, noticing that our signs change at every juncture, and that's because the multiplicity of each of our roots is going to be odd, especially for the x equal to 0 part, because that root is that root is multiplicity of 5, or has multiplicity of 5, which is odd. So we get a sign change at every juncture. Concave up, whenever f double prime is bigger than 0, that would be negative root 6 to 0. Sorry. Negative root 6 to 0, this portion right here. And root 6 to infinity, which is this portion right here. Concave down whenever f double prime is less than 0, negative infinity to negative root 6, and 0 to root 6. I even drew the little pictures in here to give us a glimpse of what this rational function might look like. Concave down, concave up, concave down, concave up. It's going to look crazy.